करते हैं हम। आज का हमारा जो है ना प्रॉब्लम बेस्ड लर्निंग, जिस तरह CEP आपने कम्प्लेक्स इंजीनियरिंग प्रॉब्लम शामिल किया है, प्रॉब्लम बेस्ड लर्निंग भी हमारा इसमें शामिल है। तो उसमें जो है मैंने 4 एक्सपेरिमेंट इधर बनाए हैं और उसकी रिपोर्ट्स भी आपने इसको सबमिट करना है। और इसमें मैंने जो 2 रिपोर्ट्स हैं वो तो मैंने इधर जिस तरह वर्ड फाइल नहीं देता था आपको, इसी तरह वर्ड फाइल में मैंने इधर शेयर कर दिए। बस उसमें आपने टेबल्स फिल करने हैं, जो कि मैंने अभी आपको समझाऊंगा कैसे करने हैं। तो उसके लिंक्स भी मैंने ये जो EEPowerGeneration.edublogs.org इसके ऊपर मैंने शेयर कर दिया है। तो इसमें अगर आप देखें तो एक्सपेरिमेंट नंबर 1 इसमें देखें वोल्टेज एंड करंट ऑफ सोलर सेल्स। अब ये जो वोल्टेज और करंट आपने सोलर सेल का निकालना है, तो उसके लिए हमारे पास वर्चुअल फैसिलिटी मौजूद है, तो उसको हम यूज़ करके हम इसको वो निकालेंगे। और इसी तरह उसके लिंक्स जो हैं वो कैसे निकालना है, सबसे पहले इसका एक्सपेरिमेंट मैंने शेयर कर दिया इधर। आई हैव शेयर्ड दिस एक्सपेरिमेंट। फॉर एग्जांपल दिस वी आर डिस्कसिंग प्रॉब्लम बेस्ड लर्निंग and you're late. And the first one experiment is about voltage and current of solar cells. And I also uploaded the manual where word file. Just you have to enter the data in tabular form by clicking these links. These 2 links are available where I will show you how to calculate the data voltage and current of solar cell, and you will calculate this data from these 2 links, and then you will enter in this manual. It will be completed. First one. Similarly, the second one, experiment 2, series and parallel connections of solar cell. Just for the understanding how when we connect these solar cells in series and parallel, what is the concept? The concept behind this you will learn in this section, and you will see here the manual is there. You can download here, and in the manual there are tables. You have to fill those tables by using these 2 links. These are the virtual facility where you online you can connect different components, series, parallel, solar cells, and then you can calculate the values and you can enter in this manual. This manual will be completed in this way. And similarly, the first manual also you will use these 2 links, and you will calculate the data online, and then you will just enter in this experimental manual, and it will be completed. And similarly, the third one is simulate the benefits of energy storage system in your PV system. Okay, energy storage. So different batteries we have. This is also the online facility. We will select different batteries and different parameters, and by using this link is available. Online facility is available, and you will click this, and under different energy storage systems and different parameters, you will analyze these things, and you will just make this report by yourself, because here there is no manual, but you can just 1 page, 2 page, just what results you have taken, and then just conclusion, what's your observation, just for 1 paragraph or 2, 3, 4 lines, just your conclusion, your findings. And similarly, the experiment number 4 is the heating systems, different sources of heating systems we will discuss here. The source of heating, source of energy systems, so for heating purpose, and we will use this link, and we will again repeat the same process. So the experiment number 3 and 4 is the one website from where we will get this data, and experiment 1 and 2 about solar cell, this is another website. Okay, 2 websites we are using today. Okay, like we have used 3M virtual lab, virtual wind system. Similarly, we are using this virtual facility. Okay, so let's start. First experiment is this one. We will just click this link. When you will click this link, you will see here, you will get this one. Now we can see here, first you will open this experiment. You will download this experiment, and experiment number 1, and this one is like this one. And you can see here voltage and current of solar cells, and what is solar cell, types of solar cells, everything is mentioned here. You can read theory about the solar cell, and similarly you can see here the open circuit voltage of the solar cell and short circuit voltage of the PV cell. All the things are available here. And then the learning objectives of this session is measuring open circuit voltage and measuring the short circuit current. These are the 2 objectives of this experiment. And what equipment we require? Solar cell, voltmeter, and current meter. It's simple. And this facility also available in our workshop lab, where the solar model, one solar module is available on the rooftop of workshop lab, but we didn't use that facility, so we are using the virtual facility in this way, okay? And similarly, the procedure is, this procedure is written here. We can see here, the connect the voltmeter to the solar cell with no load. No load, without load you will connect the voltmeter, and you will get the, and also you change the irradiance, 1000 irradiance watt per meter square, and similarly temperature 25 degrees centigrade, and then you will record the open circuit voltage. This is the first step. We will do by one, and vary the cell temperature from 20 to 40. Remember this one, you will tell me step by step, okay? Just remember this one, we will do collectively now, okay? And temperature will change from 20 degree to 40 degree centigrade in the interval of 5 degree centigrade. It means 20, 25, 30 like that, and the irradiance will be constant. We'll keep the irradiance constant, only change the temperature, and we will record the open circuit voltage and short circuit current with different temperatures in table 1. Table 1 you can see here. This is table 1, 20, 25, 30, 35, 40. These are the different temperatures, and open circuit voltage and short circuit current you will calculate from this. And click the button export, and then all the data you will find here, just you will export, and it will be exported in CSV file or Excel file, or you can convert into PDF and just print and just attach in the report, okay? This is like that one. And similarly, how does open circuit voltage vary when the temperature increases? This is the question, how it will be vary. You can analyze the curve and you can conclude your remarks. And the second one is connect the ammeter to the solar cell directly. Now we'll connect the ammeter directly. It means we are shorting the two terminals of the ammeter of the solar panel through ammeter, and you can see set the irradiance 1000 watt per meter square and temperature 25 degree. Now measure the short circuit current, and then we will vary the irradiance from 800 to 1200. We will change the irradiance, and with the interval of 100 watt per meter square. You can change the interval by your own, but here because the table is there, so you can follow this one, and keep the temperature constant. First temperature is constant, and you will change the irradiance, and you will record the open circuit voltage and short circuit current with different irradiance in table 1, and then you will export this file as a PDF or Excel file, and then you can save as PDF, and then you can print it and just attach this with the experiment like this. And so it's okay. Now how does lab report fill out the table 1, fill out the table 2 with experimental data? How does open circuit voltage and short circuit current vary when the temperature increase? So when temperature will increase, because in the first table we are changing the temperature, and in the second table we are just changing the irradiance. So in this way we will see what's the impact of irradiance on the open circuit voltage and short circuit current, and what's the impact of temperature, variation of temperature on these two parameters. So this is the overall agenda of this lab. So let's start. This is just remember this, and let's start with first. दूसरा वो भी देखते हैं ना, वो भी देख लेते हैं. अच्छा, अब देखें इसमें ओपन सर्किट वोल्टेज. अब देखें ये सोलर पैनल लगे हैं, इसको आपने ड्रैग करना है. हेयर यू कैन सी हेयर दैट दिस इज द वर्चुअल फैसिलिटी. यू कैन सी दिस इज द शॉर्ट सर्किट करंट एंड दिस इज द ओपन सर्किट वोल्टेज. इट मीन्स ओपन सर्किट वोल्टेज मीन यू विल पुट हेयर सोलर पैनल just drag it here. It will be like this, and here you will open circuit voltage, here you will connect the voltmeter. So here is the voltmeter, just drag it here. This circuit is completed. And now for short circuit current you will solar panel here, and then ammeter is here. If you will connect wrong, then it will show it's wrong. Then you will again refresh this here, and then again repeat like that, okay? And now irradiance. So what is the irradiance? 1000. We have to adjust the 1000, and temperature 25. Very good. 25, yes. Now we will submit, okay? Here when we'll submit, correct, it says correct, okay? So it will calculate like that. So this is the just virtual facility, like the physical facility we have in our workshop lab. So after some time, because the internet may be slow today, so it will take time. So okay, you got the point, and you will just calculate these values. I will show you how to calculate. When you will calculate and when you will export the data will be like this. like this. You will see here, this is the number one. How many readings you are taking? For example, I have taken 4 readings. So you will see 1000 radians, 1000. I have not changed these readings, and temperature I am changing every time. Now we have submitted. You will only get these 2 values. This is the open circuit voltage. You can see here the open circuit voltage, and this one is the short circuit current. This is the short circuit current. Okay. दोनों देखिए 2 पैरामीटर. If you are changing the 2 parameters, what you are analyzing, because if you want to analyze something, you have to fix the 1 parameter and only change 1 parameter so that you can see the effect of 1 parameter. Okay, if you will changing both, you will not observe which parameter is impacting which one, like that. That's why we are just radiance constant and temperature is like that. And similarly, in the next step, you will see the next reading. Here, for example, the collective data, for example, you can see here for constant irradiance, changing temperature, the data is the first 4 readings. And then the next readings is, you are changing the irradiance, but the temperature is constant. These readings are for this one. And you will see what's the variations of temperature on this, and you can also draw the graph if possible, otherwise no issue. And similarly, these 3 datas are you can calculate. No, because the internet is not okay, so I will not calculate. You can calculate, because problem based learning is you will calculate, not me. And the next one is, this is done. Now the experiment number is 2, series and parallel connections of solar cell. Here you can see the series connections, the voltage is increasing. And here you can see, this is the voltage graph, and this is the current. This is the voltage and this is the current, and you can see 1 module voltage if this one, 2 modules if it will be double if the modules same of same size and same specs, and third if 3 modules the voltage is 3 times, but the current is constant. Here is the parallel connections. You can see here voltage is constant, but the current is, if 3 modules current is 3 times, and the connections is like this one. And here learning outcomes. What's the learning objectives? You can see here the record the voltage and current characteristic of a single solar cell, and record voltage and current characteristic of solar cell in series. First single solar cell, then series, and then parallel. These are the 3 objectives we want to cover in this session. And measure the VI characteristics of the solar cell. For example, here set the radiance 1000, temperature 25. Now connect the solar cell to a potentiometer in figure 3. Like this, we will connect that diagram, virtual diagram like this. If you will connect it wrongly, then again refresh, otherwise it will not, software will not accept. Like here, here will be the solar cell. And you can see in parallel is the voltage, voltmeter is in parallel, but rheostat, it is actually the load. You want to change the load. So this is the rheostat, and ammeter is in, you can see both are in series because current you want to measure. So actually the circuit is this one, and voltage just across this panel, and you will change the resistance. If this resistance is maximum, I mean not infinity but maximum, it means that voltage will be the open circuit voltage, you can see. And similarly, if the resistance is negligible, 0 or negligible, that current you can see the short circuit current, like that. So in this way, now it shows that vary the value of potentiometer. Potentiometer is thus the rheostat. You can sequentially according to the table 1. Table 1 is given here. Potentiometer 0.01 ohm, 0.1 ohm, 0.3 ohm, 0.5 ohm, 0.6, and then 1. And you can see up to 5000. You can vary these values, and open output voltage and output current you will measure, and output power also. In this solar cell, just you will multiply voltage and current, you will get the power. And power is here. And here one value will be, for example, at this 5000. You can see here, okay, we will fill the table, and then next one record the value, and then okay, and export the data and just print it and plot is okay, I think. So we can cover now. And then solar series connections, connect 3 solar cells in series. That one is only 1 solar cell. That was one solar cell. Yeah? Now you are connecting three solar cells in series, because we have only the provision of three solar cells. Otherwise, you can change the 4, 5, 6, but maybe in virtual facility only three. So three solar cells in series. Measure the open circuit voltage. Same procedure you will repeat. Connect the potentiometer and as shown in figure 4, yeah, like this one. Remaining is same. Only these three solar cells are connected in series. Solar panels are connected in series. So here you can see solar cells, and here you can see connect the voltage meter in parallel like that. Okay, so then you will just fill this table like that. The readings are this one, and you will just this was series, and then parallel connection. For parallel you can see the diagram is this one, parallel, three parallel, remaining is same, and then you will calculate this table. Okay, so I will calculate only one, you can fill by your own. Okay, so in this way this manual will be finished, and let's start. If the internet is okay, then okay, otherwise you will do like. Okay, so here you can see this one. If I will refresh, internet not available, so I will just for example, solar cell you will connect it here, and voltmeter you will connect it here, and rheostat you will connect it here, and ammeter is here. Or you can change rheostat here, or is okay, I think so. And now you can change the irradiance. Irradiance 1000? Irradiance fix. Huh? Okay, irradiance fix and temperature 25 for example. Now you will submit. And the reading like good. Okay, but the internet is not available. So and you can see here that experiment, this data, like that data. You can see I have calculated this data before. No. Yes, so hotspot है? जा यार जना शोर ना कर. इंटरनेट है कोई हॉटस्पॉट ऑन कर करो यार, हॉटस्पॉट ऑन कर.
Realme 5 Pro का नाम
किधर है?
Realme 5 Pro का नाम से
कौन सा? हाँ ये वाला.
जी सर.
थैंक यू बस ठीक. अच्छा, ये बंद कर दिया, बंद तो नहीं हो गया? अच्छा, चले नहीं हो रहा अभी, इसको करते हैं. अच्छा, नेक्स्ट इज दिस वन. द नेक्स्ट वन इज series connections. Now you will see the solar panel. You will connect three solar panels in series like this one, and voltmeter is here, and you can see the ammeter and rheostat is here. And now you will submit this one, irradiance and temperature, and then you will, for example, submit.
सर वो rheostat की वैल्यू कौन सेट करना है? rheostat की वैल्यू कहाँ से?
वो इसके अंदर ही, जब आप व्हेन यू विल क्लिक सबमिट, आगे मेरे ख्याल ऑप्शन वो देगा कि rheostat 0.1, और वो ऑप्शन आएगा उसके अंदर. मैंने भी उसी में किया. यू कैन सी हेयर दैट आई जस्ट चेंजिंग द resistance. दिस इज माय डाटा, आई ऑब्जर्व माई सेल्फ, and you can see here all the exported data like this one, voltage, current, and power. You don't need to calculate. Software itself will calculate, and then generate this table itself. No need to calculate power, but this power is the product of these both. Okay.
एक वैल्यू के एक बना
जी?
के ये एक्सरसाइज लाइन
यार जैसे मर्जी कर लेना, मकसद तो जो है वो तो आम खाना है ना, गुठलियाँ गिनना तो नहीं है. ठीक है ना, तो वो जितना भी कर लें, आपको मकसद लर्निंग है. इफ यू विल लर्न इज ओके. सो यू एक्सपोर्ट 1, 2, 3 like that. It's up to you. Okay, so next one is, here is the parallel connections. The next one, these are links available in eepowergeneration.edublogs.org. I already uploaded all this data here, and you will just click experiments. These experiments also available, and also the links are available. And now this one. So parallel connections, you can see here, these are the solars connected in parallels, and the voltmeter you can see here. You will connect here, ammeter is in series, and then there is a rheostat. Then you will again different values you will test, and you placed all the components successfully. Otherwise it will show the error. So in this way you can see here you can see the first data is recorded. Okay, and now you will just, the value was, resistance was this one. Click for resistance value. Here you can see, if I will click the resistance, this one 0.1 and then 0.05. Next, you don't need to go here every time. Just it is also showing here. Just you can see 0.05. Just copy and then you can paste it here. Control V and then submit. The second value will appear here. Okay, and you can see here after some time, the second value is appeared. In this way, you will record all values, click the values, next one, and all values you will enter, and then you will submit and all the data. And then in the end, you will export table. Here, you can see the export. Before exporting, for example, the next value, for example, we want to take, and then in the end, you will draw the PV curve, because we have only two values like this one, otherwise it will draw, and IV curve, because values are only two, so maybe it will not draw. So you will take more data, for example 0.07. You can change the resistance. You don't want to follow this pattern. Maybe you can change resistance of any value. You can enter. This is the provision available in this visual. And this third one, and then for example 0.1. Then submit. These are the parallel connections. Similarly, the previous one 0.1 and then 0.5, for example. So in this way, for example, draw VI curve. So you will see something, V curve you will see here, like that one. This is the same pattern we are following. VI curve of this panel, and similarly draw PV curve, and you will see the PV curve. And now you want to save it here. For example, here you can see VI curve, this icon. You will click it here, print or save as JPG or PNG. For example, JPG, we want to submit it. This is the parallel connection, experiment number 2, and here JPG, for example, chart. So you can see it will be like this one, and you can print it and you can attach this one. And similarly PV curve, again here JPG or print, something like that. So in this way, VI PV curve export table. So you can export the table here, data, and here just click it here, and you will see that in Excel file the data will be recorded in this way. And similarly, the next one is download block diagram also. If you want to download the block diagram, you can also. Otherwise, for example, in the start, I have shown you that you can crop like this. If it will not download, no problem. You can crop, for example, here, sniping tool. You can just in the start, the diagram you have to mention, because that diagram shows what's the actual connections are. Okay, so you will draw. Otherwise, download this block diagram like that. So these are two experiments. Here you can see multiple times clicking. So here the block diagram is also downloaded. So in this way, you can perform these experiments. And next, multiple times. So now the next one was experiment number 3. Here, they simulate the benefits of energy storage in your PV system. So this link is available. When you click this link, you will the link will appear here, and this storage and this heating. So the link will be like this one, storage. And here you can see simulate the benefits. This is another virtual lab, you can see. And here different batteries, for example 6.4 kilowatt hour. This is battery, and similarly the different batteries are available. You can choose for 4, 5, 6, for example, and experiment backup mode. You want backup mode, 40% capacity, or you don't need backup. You just want to like that, 40% backup. And then energy consumption, per year energy consumption, how many kilowatt hours, how many units. For example, you can calculate your home units in your home. For example, Sama, how many units you are consuming at your home? Average about 300, or you can say. If it is 300 units, for example, so बारते हैं 3600. So we can write it here, 3600 units per year. Family, your family are employed, huh? So family, okay. So you just simulate. When you will simulate, you can see here, it is calculating. So here you can see self-sufficiency, 23% energy will be available with their storage system. If you are selecting this battery, the rating of this battery will be this one. If you are selecting this battery, and 40% backup you need, so these units, only 23% self-sufficiency, you don't need rely on grid. For example, here you can see self-sufficiency, and then power, you can see the level summary is here. You can write this summary as it is. The level of self-sufficiency increases from 18 to 23%. Before it was 18, now it is 23, but maybe before your will be different. This increase of 5% corresponds to 92 kilowatt of energy that is used in your own household instead of being fed into the grid. So this is the, you can check here if you can check if the selected energy storage is compatible with your inverter. So you can see here the energy storage system is compatible with your inverter or not. The data is available, you can see also. And for example here, these are the different, for example, this is the overview of battery compatibility. And because this company is also, you can see selling their own inverters. We don't want to focus any other one company. Our focus is just whether inverter is compatible, but no issue, I think so. In the market, we will see in our market this battery is compatible or not, like that. So in this way, you can see here, you will get this, and here you can see this is the symbol of grid. It means power from grid, and similarly not enough data for calculation. And here self-sufficiency, you can see here self-sufficiency only 23%, remaining you will take from the grid, like that. So in this way, I will say, for example, 100% backup I want from value, maybe maximum of 60. It shows 60, not more than that. And if I will simulate again, you can see here. So in this way, it is taking time. So in this way, and now you will change, for example, different 22 kilowatt hour battery, and then again you simulate under different parameters, and you will see this analysis. This is the conclusion of this analysis, how much self-sufficiency you have, like that. So this graph, maybe you can just, I think so, there is no facility to print this graph, so you can like this one, okay? So just snipping tool and just paste it here, okay? So in this way you can, and conclusion in summary you can write this line. So this is the PV system, and then next one is experiment number 4, simulate the benefits of heating system. Now heating systems, when you will click it here, this is the heating system. You will get this link and heating system, the same website. And here you can see we have the different sources. If we want to heat the water, so the output is how much yearly hot water supply is available, 40%, 30%, like that, hot water available. And which source of heating we are using, oil, gas, air heat pump, geothermal heat pump, or pellets, biomass, something different materials. And you can see heating, for example, oil. Now for oil you can see the feed-in tariff is by default, you cannot change, because otherwise you have to search out in Pakistan what's the oil tariff in Pakistan, feed-in tariff. And gas tariff you will see it is also same, not same, it's, I think so, internet not available. So here if I will change, okay, it shows the same is okay. So oil tariff, for example, your boiler size is 150 liters, 150 liter boiler, okay, and load profile is family or employed. Energy consumption, similarly, if you have energy consumption 3600 units per year. Electricity cost, how much electricity cost, it is in euro per kilowatt hour, but you can convert rupees into euro. For example, maybe how much electricity cost we have in our bill, but with oil, this is only for oil, with oil maybe 15 rupees or more, huh?
सर 20-25 हो जाती है
20-25 करो, तो बस ये 20-25 है, उसका यूरो निकालेंगे तो हमारा 0.0 समथिंग ही आएगा मेरे ख्याल में। अच्छा, इसी तरह फीड इन टैरिफ ये हो गया। ओके, सो यू विल एडवांस सेटिंग्स आल्सो अवेलेबल, फॉर एग्जांपल लो एनर्जी बिल्डिंग, योर बिल्डिंग इज लो एनर्जी, न्यू बिल्डिंग, ओल्ड बिल्डिंग, persons, how many persons are living, up to 8, temperature, boiler temperature, how much minimum and maximum, and then there is a heating cost, these, and then you will simulate like that, and you will see 48% hot water will be available under these input parameters. If the parameters you are setting and you are using oil, so the 48% hot water will be available from this facility. Okay, in this way, and also heating system lifetime 2.2 years, and savings 107 euro per year you are saving like that, and yield 8.5% like that per year. Recommended heat rod power 3 to 4 kilowatt. So you want you have to use recommended heat rod power is 3 to 4 kilowatt like that, and the self consumption increases from 40 to 48%. This increase of 8% correspond to extra units of energies that is used in your household instead of being fed into the grid. So this is the actually hot water availability using this oil. And similarly you will repeat with gas input parameter, air heat pump, then geothermal heat pump, and then you will use the pellets. Under different scenarios you will just simulate, and you will conclude your remarks, and you will enter in the lab. Okay, so this is the end of this problem based learning. I think so it is enough, and you have to compile the report and you will just submit. Okay, so you will CR will decide the date, and you will submit. Okay, I think so this is finished.